We'll wait for some time and we'll solve the assignment question for week 5 today. So week 6 today. And not exactly solve the assignment questions, but yeah, I'll go through the concept that solve the assignment questions. So yeah. I hope my
Hope
screen
my
is
screen.
hello.
Hello.
Yeah, I hope my screen is visible. Um, we'll start with the content of week 6 now. Um, yeah, give me a second. So while we're waiting, so if you have any doubts regarding the assignment questions or anything in this week's content, like anything particular, you can speak up or just write in the chat. I'll try to clarify that. Yeah, I got a question. Good evening, sir. In week 5 assignment, we got a question that TCP support broadcasting, but it doesn't. But the solution you gave is it support. Which one is correct, sir? I gave the solution. Oh, the solution that you saw in the website. You're talking about. Let me see. Um, could you please clarify? Like, is this the solution I gave, or it's in the NPTEL website? Okay, in the website. So see, the thing is that I don't have any control over the website. What I have control over is so what I do is that I just come in the week. I explain the things that was already done in the previous week. Also, some explain concept that will help you solve assignment questions. But I don't um, give the solutions in the website. So if you have any doubt regarding the website solution, you can write to the NPTEL people who are managing that, because I don't have any control over the solution or the results or anything. I'm just yeah, just um, give the tutorial. And I think I didn't say that the TCP is connection, like TCP is doing the broadcast, because TCP is connection oriented. TCP is connection oriented. That means a three-way handshake is first done, then only you can transfer data between the two things. Broadcasting is like, you take data and put it to everyone's device. So this is device 1, this is device 2, device 3, device 4, device 5, device 6, and so on, device, let's say n. But TCP is connection oriented. Uh, it um, it first send the data for first make the handshake, then do the data transfer. So, questions? Okay, sir, thank you. So if anyone else has any questions, I can start with that. I'll ask you to mute. Yeah. All right, so we'll start with the week 6 content. Let me go to the course materials. So in the network layer, so what it says is that the network always work in an hierarchical fashion. Let's say you have a lab, let's say software lab 1, and there is some pieces like this, and it's forming a network. And there is another network like this. It has some pieces. Let's say software lab 2. To connect these two networks, what you do is that we put a router in between. Okay, this is a router. But like, if you, the reason I said hierarchical, because so if you see, so this is your software lab. So if you go a bit one level up, you can see there is a network of CSC, computer science and engineering. Inside that, there is your software lab 1 network, and there is your software lab 2 network. They were connected through the router. This router is going out, and here, let's say you have triple E branch network where there is triple E lab 1, there is lab 2, there is a router here, and it is getting connected with each other using a router again. Okay. Similarly, if you go a bit up, so you'll find here is your university 1, that is your CSC, is your triple E, and all these things connected to a router. And here is your university 2, or like, let's say BSNL network, and it is your not CS, like local. Here is your private and stuff. It's going to the internet and all these things. So the point of discussing all these things is that all these things are hierarchical. So if you go inside one set, you'll find a bigger set inside it. So to identify this network, so what you do is that we assign an IP address to this network. Okay. IP address belongs to a network, and so it will be like, it will be like a the address to identify a network as well as a host inside the network. So if there is a host inside this network, this will also have an IP address. Okay. So if I give you so it should be in such a way that if I give you the IP of the network and IP of the host, you should be able to find that IP of the host belongs to IP of the network. So it's the way it is designed. So if I give you a lot of host computers IP address and also like give you the IP address of certain networks, you will be able to say that which IP address belong to which host. Sorry, which host belong to which address, which network. So it's a hierarchical thing. So if I so the suffix, the prefix of the network address will have the same. So the address of this and this network will be same to some extent. If the address is like this, until this point, it will be same for both of the things, and this will be different. Okay.
So this comes, this brings the necessity of IP and IP address. So we'll look at the structure of IP address now. So structure of IP address. Structure of IP address is like this. Here is a complete address. There will be one yeah, so there will be some there will be network address, and this will be your host address. Okay, so if you go into the network and there is a host inside this network or computer, the network address of this host will be equals to the network address of this network. Okay, so that's how you know that this host belongs to this network. We have so many people. I think we have some new people as well. So if you have any doubt regarding this week's content of this week's assignments, you can ask me now. I can clarify the assignment doubts for week 6. The deadline is on March 4th, I guess, tomorrow. Okay. So moving forward, when we started with the IP address nomenclature, there are like two methods. First one was what they created earlier. Um, so there are like there's two methods. IP address. First one was classful addressing, and the second one was CIDR notations, or that is CIDR, that is classless inter domain routing. Okay. Classless inter-domain routing. So first we'll go look through the classful addressing. Uh, okay. In the classful addressing, there are like 5 classes. Class A, Class B, Class C, Class D, Class C. So what they did is that they said we'll divide the class into different. Uh, so we divide the type of address into different type of addresses, and we'll fix some of the number of bits for network addresses, and we'll fix some of the address for the bits for the host addresses. And so with that, we will use the first few bits. So we'll use the first few bits to identify the class, and then we will assign some things to specify which class is used for which one. So starting with the first one, like class A. So class A will identify if the first bit is 0 and next 7 bit is used for network, and the rest. So there is total, like the IP address is a total of 32 bits. Okay. So rest 24 bits will be used for host. Okay. Then there is so class B. Okay. In class B, it will be identified by 0, 1. Sorry, my bad. 1, 0, and rest. Put dot here. So let me, yeah, so the rest. 8, 8, 8, this is 6. This is your network, and this is your host. Okay. Then class C, where the prefix is 1, 1, 0, and the 5 is 8, 8, 8. This all is network, and this is your host. So the thing is that what they did is that, so the notion about this network and host is that number of hosts that can be present. So first bit, like will represent number of network that can be present in the entire world, and within one network, how many hosts can present maximum. So this is just a binary operation. So if there are like two bits total, how many possible combination is there? There's 2 bits, right? So bit 1, bit 2. So if you take 1, 1, 1, 0, 0, 1, 0, 0. Okay. So if you count this, it is 4. That is equal to 2 to the power 2. Similarly, if there are like 7 bits for network, how many number of hosts will be possible? How many number of possible combinations will be possible? 2 to the power 7. Similarly, if we calculate all these things, how many number of hosts and how many number of network is possible. So let's just calculate about network. How many network is possible to represent? How many network we can uniquely represent with this representation? So if you look at this, there are 7 bits left for networking. So that will be 2 to the power 7 for class A. For class B, there is 6 plus 8, 14, 2 to the power 14. And for class C, it will be 8, 8, 16, 5, 21, 2 to the power 21. So these are the type of this is the maximum number of network that is possible to represent in class C IP addresses. Okay. And similarly, if you go to class D, okay, you go to class D. Class D is starts with 1, 1, 1, 0, and it's not unicast address. So apart from this, all others are multicast address. Multicast. So the difference between unicast and multicast is that unicast, there is device 1, there is device 2, there is device 3. If I am sending only to device 2, that is unicast. If I am sending to device 2 as well as device 3 at the same time. That is called multicast. Okay, let me put another device D3, and if I sending to everyone D1, D2, D3, that's called broadcast. Okay, and device D is for multicast, and sorry, the class D was for multicast, and class E, which starts with 1111, is so reserved for future use. Yes, experiment. Okay, so by discussing, so if you have any doubt on anything that I have discussed just now, you can unmute yourself or um, just tell me what it is. If you have any doubt, you can ask. Because if you have seen the question in the assignment, I just answered two of the questions. I'll not name the questions or the number of the question, the serial number of the question, but I answered two of the questions that you have in the assignment. So if you haven't got what I'm trying to say here, you can stop me now and I'll explain it again. You can put it in the chat. Okay, perfect. So I discussed two assignment questions. Now we'll go to assign next assignment question, but I'll not tell which uh, which one is it. So you just have to figure it out by yourself. Once we are done with all the assignment questions of week 6, we'll end this meeting. Okay. Okay. So we counted the. So if these are the number of hosts. So if these are the class A, B, C, D, and E, we counted the number of the number of network that I can have in each class. And now we'll go for number of hosts that we can have in each class. Okay, so the number of hosts. Okay, so starting with starting with class A. So there's two things. So if a network is like this, like if let's say 192.127.0.0, let's say like this is a class B address, let's say, okay, and so it's like this. So this represents your network, let's say the network part, which network to this IP address belongs, and this represents the host it belongs. Host, okay. So if you give me a second. Yeah. So yeah, so the host. So when in the host part, there is all 0. So in host, so we're just in the host block, let's say. In the host, if you have all zeros in host, so that is the network address. So you see, so I'll just draw it again here. So if there is a network, and there are a couple of hosts in it. Okay. Okay. This network has an address, let's say 192.127.0.0, and this will have address such as 192.127.0.1. This will be 0.2. This will be 0.3, and same thing, and this will be 0.4. You see all these things 192.127 is same in the network address as well as in the host address. So there's the network address. Okay. Apart from which are same, if you put everything as 0, that will represent the network's address. Okay, so this network's address. So this 00 thing is reserved for the network address, and it cannot be used to represent any host. Also, if you put 111, like 111 and in all the bits, so it's this like 0 0 0 0 0 0 0 0 dot 0 0 0 0 0 0 0, sorry, 0 8 bits, right? 0 0 0 0, just like that. If you put 1 at all the places, so if you put 1 at all the places, like 1 1 1 1 1 1 1 1, 1111111. That means, so if you see any address that looks like, so this will convert to your 256, and this will be converted to your 256. So if you find any address that looks like 192.127.256.256, you find something like this, then if you find something like this, then here's the broadcast address. Is the broadcast address. Okay, it is the broadcast address, and so this also cannot be assigned to any computer. So if any router find this address, it will just take the packet and send it to everyone in the network. So it doesn't have any um, fixed device for that. Give me 1 second. Sorry, there was a call. My flatmate's phone got stolen, so bit of hesitation here. Anyway, um, so this is the broadcast address, okay, and this is broadcast. We cannot use it. So if we go like this, so just so if the thing is, so we just need to count how many addresses are left for the host. So if we do this for just two numbers, let's say that we have 2 bits for representing the host. That is 00, 01, 10, and 11. We deleted all these things, like for a 0, it is the network address, and this is the broadcast address. We're left with this two, right? This is our usable host address. Okay, so this is our usable host address. So this is our usable host address. So this is our usable host address. Um, so earlier we counted how is the number of so possibilities that is 4. Now it is 2. The formula for this will be 2 to the power n minus 2, right? So it is 2 that is equal to 2 to the power 2 minus 2 equals to 2. Okay. Similarly, if we develop on this and try to go to our classes here. These are classes. So if you go here, so this is the network. Okay, I'll just put it as network address. Number of networks. Okay, but there is something called number of, so we can also count the number of hosts as well. Okay, so in class A, we have 24 bits per host, so it will be 22 to the power 24 minus 2 number of hosts. For class B, similarly, it will be 2 to the power 16 because 16 bits are for the host. The 16 minus 2. And for class C, it will be 2 to the power 8 minus 2. This will come around to be, let me calculate. It's come around to be 2 to the power 24 is 1677216 minus 2 is 214. And this will come out to be 2 to the power 16 minus 2, that is 65,534. And this will come out to 2 to the power 8 is 2 to the power 8 is 256 minus 2 is 254. Okay. So this answers one more of your assignment questions, but I'll not tell you which one. Um, okay. Okay, perfect. So this is done. So if you have any doubt on this, you can ping me now. I can tell. Okay. So then we'll go to our next topic, that is subnetting and supernetting. Okay. So if there is, so I told about your CS network. There is AAA network, and there is your university network, uni network. So this is called, if you consider this as network, this will be a subnet. This is your network. This is your subnetwork. Subnet 1, subnet 2. Okay. So if you are splitting your network into different networks, this is called subnetting. When you are combining different network to form a bigger network like this is called supernetting. Okay, so now you got the definition of supernetting. Supernetting is combining different network to form a large net, combining multiple small network in a single large network. Subnetting is splitting the large network into multiple small network. It's very straightforward. There is a question regarding this. You can also solve this directly. Then, okay, so this is the subnetting and supernetting. So from the concept of subnetting and supernetting, we go to the concept of CIDR notation. I said here, you see, there are two type of notation in while denoting IP address. One is classful IP addressing. Second one is CIDR notation, or the classless interdomain routing notation. So we have done with the classful notation. We now discuss CIDR. Okay. In CIDR notation, what we said is that we said we don't really need to fix the IP or the class of the network size as well. So what you can do is that we can so there are like, how many bits are there? So 32 bits are there, right? So 32 bits are there. 8, 8, 8, 8. So in 32 bits, you so in 32 bits, 32 bits. So let's say a network want to use this bit for his network, and this for host. So the address will look like this: 192.180.83.235/16. That means that means 12, right? Sorry, if you write 16, that means first 16 bits are used for host and rest are used for network. So it will be allotted based, like if you have a smaller network. So earlier you have to choose one of the class A, B, C, or D, one of the network. But now you can choose very um, um, efficiently or easily which network, like which class of representation that you want, because you can you can also do it like this: 191.180.83.235/1. That means, or 2. That means in your network, there will be only total of 2 to the power 2 minus 2, that is 2 hosts. So if you know that there is only 2 hosts in your system, you can just order an IP address of, you can also get you can only get an IP address that looks like this. But if you want if you want to have a if you want to have a IP address that looks like that, if you have a huge number of hosts, let's say around 1,000 hosts, so you have to find 2 to the power x minus 2 equals to 1,000. So this x is the number of bits that you need to represent the host. So it will be 2 to the power x equals to 1,002. So you take log in both sides, x equals to log 1,002 base 2. that will come around to be, so how many to the power 2? So 2 to the power 10 is 1024. 2 to the power 9 is 5, 512. So if you take 9 bits per host, you'll not be able to accommodate 1000 hosts. If you take 10 bit per host, you'll be able to accommodate a lot of hosts, like 1024 hosts, and 1000 is less than 24. So yeah, you can accommodate that. So um, so uh, your notation will be 191.180.83.235. Let's say it's a demo of one of your address and slash then 10. So earlier, the internet governance, or like, the people who are providing the IP address for your system or for your computer or for your organization, they used to have all this class, like, you have to choose from which class does your organization belong. So if your organization have a very less number of hosts, so you see the number of hosts that you can have here is 254. So if your organization will have a very small and it will maximum have a 254 routers or computers, you can take class C address. If your organization have much more computer, like 65,000 around, you can take this one. If it is more than a million, it's like 1.6 million, then you can take this. But here it's very flexible. You can choose a number of computer that you can have max, then you can get computer router, then you can get the corresponding IP address range for your organization by this, like, just slash 10, like the prefix will represent your network and the next rest will represent your host. Okay. Okay, so this is the CIDR notation. Um, in the CIDR notation, so I'll show you, like, what is the network address and what is the host address. So let's say you want to find how many people you can, what is the address that you need when you are, what is the structure of the address that you need when you are accommodating, let's say, 4,000 hosts. Okay. So when you're accommodating 4,000 hosts, you start with this equation and you'll end up with 2 to the power x minus 2 equals to 4,000. 2 to the power x equals to 4,002. That implies x will be nearly equals to 12, I guess, because 2 to the power 12 is, that 2 to the power 12 is 4,096. So you put this is 12, you'll solve your problem. You can say greater than equals to. Yeah, instead of equals to. X should be equals to 12. It should be greater than. It should be greater than equals to this. Okay. Greater than equals to also. It's greater than equals to. Okay. So your IP address will look like this. Why? Yeah. 180.235/12. So if this is one of the hosts in this network that you bought, what is the broadcast address? The broadcast address is, so what you do is that, so your last 12 bit is, so you just convert 191 to 1, so there will be some 191. So last 12 bits is your host. So this first 8 bit is host and this 4 bits from this is host. So you put your 191, 180 as it is. Then there is 83. 83 is represented as, so 83 is 0 here, 64 plus 32, not 32. 127, 64, 32. Then there's 16. 63 plus 6, 64 plus 16 is 64 plus 16. 64 plus 16 is your 60, 74. 64 plus 16 is 80. 80. We need 83. So 8 will be 0. 4 will be 0. 1, 1. Okay. Then you have 235. 235, I guess. 15 is not there, right? And so 127, 64, 32. 235 is 127, 64. What is the binary of 235? Yes, sir. 223. Then if I put 16, no, 16 will be, it will be 0. I put 8. Yeah, 8 is there. Then no 4, 2, and 1. 35, right? Oh, sorry. G 0, 1, 1, 0, 0. So this will be 235, I guess. 223 till here. Then you put 8, 16. Sorry, 8, 4, 12, 235. So this is the address and /12. That means all this thing 8 and all this 4. So if you convert everything this all of these things to 1, 1, 1, 1, 1, 1, and rest are same. 191.180.0101. So this is your broadcast address. Okay. There is 2 things. One is broadcast. One is one is direct broadcast. One is limited broadcast. Direct broadcast is broadcasting within the network. So if you are broadcasting it within the network, within all the computers in your network, that is called direct broadcasting. If you broadcast it to all the network in the internet, like all the devices, that is limited broadcasting. Let me see. Yeah, sorry, it's the opposite. Limited is the within that, and direct is the everything. But yeah, so if you put all these things and replace all these things to zeros, all these things replacing 1. If you replace everything to 0, you'll get the address as 191.180.0101. Then here it will replace with 0000 dot 100. That will be 191.180 dot, and this will be your 64 plus 16, 80 dot 0. This is your this is your uh, uh, oh, sorry, I completely misspoke it. So this number 12, so this number that you see here, the n, It represents the number of network, not the host. My bad. I was completely under trying something else. So this number 12 represent the number, not the number of host, not the network. So you have to take uh, 12 from here, this side, and convert it to um, uh, maybe let me check actually. Yes, first 12 bits are used. First 12 bits are used for networking, and the rest are used for host. My bad. So if I convert this 191, it will be 126. Sorry, 127 plus 64. 120 plus 64 is uh, so 100,000 dot 180 is 127, then 32. And let me calculate. 32 is 9, and there's 32, then 16, 95. Yeah, so 152, then 0, 1, 1, 175, 5, right? So 8 will be 0, 4 will be 1, 12 will be 0, 1, 1, dot your 0, 1, 0, 1, 0, 0, 1, 1, dot 1, 1, 1, 0, 1, 1, 0, 0, slash 12. This means the first 12 bits is 8 plus 4. 12 bit is host. Okay. To get the broadcast address, you put all as 1 for broadcast. That will be 1100 dot 1011. Then all 0 dot all 0 dot all 0. That will come out to be 191. This is, if you convert it to decimal, it will be 127. This is 32 plus 16, 42, 48. 48 plus 127, 48, 48 plus 27, 127 plus 2 plus 16 is 175 dot 0 dot 0. Okay. Broadcast. If you put 1, if you put 0 for subnet mask, or network address, or subnet address. Okay. So if you put 0, your resultant will come around to be 1100,000 dot, because host will not touch 1011. Then you put 00000 dot all 0 all 0. Sorry, my bad. It is all 1 all 1. And I don't know how I'm making all these mistakes. 1111 1111 1111. So this is like 256 dot the broadcast address, and all 0 for the this is all 1111, and this will change to not 175 plus 4, no 8, 4, 12, 6, 15, 190. 90. But if you look at this, it will be 191, 175, 0, 0. Okay. Okay, so this completes your CIDR notation also. So I'll just tell you about a bit of IPv6 because there are a couple of questions that covers IPv6. Uh, the IPv6 address looks like this. Like it's a 6, 5, 6, 3, 4, 5, 6. This last one is not there, and it is all in hex. Hex. So if I put something like this, some address, then some address, and then I put double dot, then I do it like this. That means that there is 4 places, and there is the missing 2 places. 2 places is all 0. So instead of showing 0, 0, I just put double dot. So if you just put like this, it is a valid IPv6 address as well, because that means here is some value, here is some value. The rest 4 places is all 0. Okay. But if you put like this, 3, then 4, then it is not valid. Okay, if someone is asking what is the valid IPv6 address, you have to count the number of values here. If it is less than 6, then there should be double dot in between. If there is no double dot and less than 6, it is an invalid IP address. Invalid, invalid your um, IPv6 address. There is one question like asking about the size of IPv6 datagram. It's 40 bytes, but everyone knows there is a figure also as well. So yeah, you can solve that question as well. And I think I covered most of the questions now. There are a couple of questions that is left, like ICMP pool, in current internet control protocols, like all these things, true or false, it is true. So I'll not discuss, like 2 or 3 questions left. I'll not discuss that. If you go through the video again, you'll find this answer to the questions, most of the questions. But for rest, you can solve it on your own. Yeah. So we'll stop this meeting now. So I'll we keep recording for 5 more minutes and solve it. But yeah, so you can, if you want, you can leave the meeting now. It's fine. Okay. See you next week. If you so all these videos get uploaded to my YouTube channel. If you haven't subscribed to the YouTube channel, you can subscribe it now. I'll put this thing in this chat. Subscribe it. Please press the bell icon for you to notify about the new video. All right. See you next week. Bye bye.